Okay, you've arrived at gotomath.com. Let's go down here and we are doing optimization problems. Of course, this is the problem list for right now until I add to it. We're looking at 1-2. So we clicked it once and it came right up. Find two positive values that has a sum of 15 and their product is a maximum. The product is a maximum. Right, the sum, now you notice it says two positive values that has a sum of 15. So I'm writing this down here. You can take this time, write it down. Sum of 15, and their product is a maximum. Is a maximum. Okay, I got it. Let's move over to the whiteboard. Okay, so we want to find two positive numbers. We'll let the two positive numbers be x and y. Okay, two positive numbers. Um, okay, so I'm going to write the primary equation here. So we want to maximize. I'm just going to write max. We want to maximize their product. We'll call the product z instead of p there. Z is equal to x times y. Okay, max their product. And then our secondary equation is going to be, it says that their sum is equal to 15. That their sum is equal to 15. And the sum has a sum of 15. Okay, I was just making sure. Alright, so this is how we're going to set this up, right? So we're going to solve for either x or y in this equation and then plug it into here. In other words, we want to get this equation in terms of one variable, either x or y, it doesn't matter. And then we just take the derivative, set it equal to 0, and solve for x or y, whichever one. But let's just go ahead. I'm going to go ahead and stick with solving for y. Okay, so let's just do this right here. So y is equal to 15 minus x, right? So we solved for y in this problem. And now what we're going to do is take this and plug it into here, right? So we'll do that right down here. So we have z is equal to x times 15 minus x, right? And let's go ahead and distribute that x across. So we end up with 15x minus x squared, right? Now the next order of business is we want to take the derivative. We want to take the derivative of that thing. So let's do that. So we have z prime is equal to 15 minus 2x. 15 minus 2x. And then what we're going to do is set it equal to 0. Let's do that. Let's just do that right up here so I don't have to keep scrolling down the screen. Alright, so we set this equal to 0. 15 minus 2x. And then we just solve for x in this problem. In other words, we're looking for that critical number, right? Remember we put c in for here and said, okay, solve for c. Alright, so we got 2x is equal to 15, bringing this over. X is equal to 15 over 2. 15 over 2. Now the question is, how do we know that this is actually a min or a max? And of course, what you could do, and I'm not going to do this in all the problems, okay? We're just going to do this in the first couple problems or so. But to test if this is a min or a max, you can put this on the, I keep thinking this number should be something else. We could put it on right here and then test whether it's a min or a maximum. And you can also use the second, remember doing the second derivative test where you took the second derivative? I shouldn't probably do this, but if we took the second derivative, okay, we end up with -2 actually. Would the second derivative work on this? And it turns out that it's since this is negative, we know that it's concave down. Remember, no matter what we plug in for z, it's going to be concave down. Therefore, we know that every single point on the number line is going to be negative, which means it would be concave down everywhere. So, um, you know, that's one way you can use the second derivative. But anyway, we could also use, let's see, what the heck is this? This is a 15 over 2. 2 goes into 15. 7. 7 times 7. 2 goes into 15. It's too early in the morning for me. 7.5, obviously. So you can always use 7 here as a test point, and then we can use 8 over here as a test point. So taking 7, plugging it into the derivative, you get 15 minus 14, which is positive number, right? Positive, so we know that it's increasing. And then if you took 8 and plugged it in, we get 8 times 2 is 16, right? And 15 minus 16 is a negative, and we know it's decreasing. Okay, so we know there's going to be a maximum that's going to occur here, but we could also have done the second derivative and said, oh, this is concave down, right? Concave down, remember, and been done with it. But anyway, that's okay. You need to see both ways. Okay, so x is equal to 15 over 2, and now y is going to be equal to, and we come up here, right, and use this right here. So we have 15 minus 15 over 2, so that's going to be, let's see, 30 minus 15 is what? That's going to actually be 15, right? 30 minus 15 is 15 divided by 2, so you get 15 divided by 2. Yeah, no kidding. It's like, duh. Anyway, 15 over 2. Okay? So we got our y and our x and our two numbers. And of course, you can always find out what that product is by multiplying them together to get the actual, find out actually what that is. Okay, so we got 15 over 2 and 15 over 2. All right. 15 over 2 and 15 over 2. Okay. All right, so we set up our primary equation, we set up our secondary equation, and then of course, right, you know how to do that. Get this all in terms of one variable, plug it in, take the derivative, set it equals 0, solve for x. Anyway, so there you go. So come on by, practice that, and maybe I'll see you there. Okay?